Let us solve numerical on transformer EMF and efficiency. Iron loss of a 70 kVA single phase transformer is 600 watt and copper loss of 1.5 kilowatt at full load current. Calculate efficiency at full load 0.8 lagging power factor. Second, efficiency at half load unity power factor. So this numerical is straightforward or on formula. What is given? kVA is given, iron loss is given, copper loss at full load is given 1.5 kilowatt. First they are asking what is efficiency at full load when power factor is 0.8. So efficiency at full load is kVA into 10 power 3 power factor by kVA into 10 power 3 power factor plus iron loss plus copper loss at full load. So putting values 70 into 10 power 3 but power factor is 0.8 divided by 70 into 10 power 3 into 0.8 plus iron loss 600 plus copper loss 1.5 kilowatt means 1.5 into 10 power 3. So it comes as 0.9638. Our efficiency at full load is 96.38. Coming to second, efficiency is asked at half load, that is fractional load. So for half, what will be N will be 0.5 and power factor is 1. So efficiency at any fractional load is N kVA 10 power 3 power factor by N kVA 10 power 3 power factor plus iron loss plus N square PCUFL. So putting values and efficiency at half load N equal to 0.5. So 0.5 into 70 to 10 power 3 into 1 by 0.5 into 70 10 power 3 into 1 plus iron loss plus N square PCUFL. So N square 0.5 square into 1.5 into what 10 power 3. So this comes as 0.9728. Therefore efficiency is 97.28%. Let us see for next numerical. A single phase transformer of 80 kVA 1000 by 250 volt 50 Hz iron loss has iron loss of 500 watt and copper loss when primary carries a current of 50 ampere is 400 watt. Find cross sectional area of limb if working flux density is 1 Tesla and number of primary turns are 1000. Also efficiency at full load 0.8 lagging power factor. Right. So let us solve it. So what is given? 80 kVA. 80 kVA 1000 by 250. 1000 by 250 volt 50 Hz transformer. Iron loss is given 500 watt and copper loss is 400 watt when primary current is 50 ampere. Copper loss is 400 watt when I1 is 50 ampere. So it is not known whether this copper loss is full load copper loss or not, because if I1 is rated current, rated full load current, then only we can say this is full load copper loss. So rated full load current can be calculated from 80 kVA rating with 1000 by 250 volt voltage rating, right? What is first question? They are asking what is area of limb when flux density is 1 Tesla and primary number of turns are 1000. Second is efficiency at full load they are asking and power factor is given 0.8. So first we know EMF equation E1 equal to 4.44 F phi m N1, but phi m can also be written as Bm into A. Therefore and E1 is given. What is it? It is 1000. So E1 can be written as 4.44 F BM into A annual. Put values, it is 1000, 4.44, 50, BM is 1, A is unknown, and this is 1000. So 1000 cancel, A is coming as, putting these values, we will have 4.44 into 50, its inverse, that is 4.5 into 10 power minus 3 meter square as area. Now for finding efficiency at full load, we must calculate full load copper loss. Rest thing is known, kVA, power factor, iron loss, but copper loss is also given, but it is not known whether it is full load copper loss or not. So full load primary current I1 full load can be given by kVA, we know formula, kVA by V1 into 10 power 3. So 80 into 10 power 3 by what is V1? V1 is same, 1000. So we got 80 ampere as full load current. Therefore, this copper loss is not full load copper loss, because this is copper loss when current in transformer is 50 ampere. That means transformer is not fully loaded, it is partially loaded, and that fractional loading can be calculated by formula. We know I at any fractional load N is given by NIFL. Therefore, I1N equal to N I1FL. So 50 ampere is given, fractional loading current, N is unknown, and full load current just now we have calculated. So N comes as 5 by 8, that is 0.625. Therefore, efficiency at full load can be calculated. Before that, you find out copper loss at full load. So what is formula? Copper loss at N by N square. That is what? 400. Copper loss is given as 400 at fractional load, divided by 0.625 whole square. So it comes as 400 by 0.625 whole square, that is 0.625. So it is what? 1024 watt, right? Therefore efficiency kVA is how much? 80 10 power 3 into power factor divided by 80 into 10 power 3 into 0.8 plus iron loss is fixed 500 plus copper loss is just now appeal 1024. So this comes as 80 by plus 500 plus 1024, 0.9767, that is 97.67%. Right. Let us go for next numerical. Say 8.4. 40 kV transformer has iron loss of 450 watt. So what is given? Let us write. kVA transformer has iron loss of 450 watt. Full load copper loss of 850 watt. So full load copper loss is also given 850 watt. Power factor, if power factor of the load is 0.8 lagging, power factor is also known 0.8 lagging. Calculate full load efficiency first, efficiency at full load. Second, load at which maximum efficiency occur. Second, load means kVA at eta max. And third, they are asking what? Maximum efficiency. So eta max is asked. Right, let us solve it. What is full load efficiency? First, kVA 40 10 power 3 into power factor by 10 power 3 into power factor plus iron loss. Iron loss is 450 plus copper loss 850. So this is what? Plus 850. So this comes as 96.09%. Second, kVA at eta max. We know what is formula: kVA under root iron loss by copper loss. So kVA is how much? 40. Iron loss is 450. Copper loss is 850. So this comes as 29.1 kVA. Right. Third is eta max, maximum efficiency. What is formula? kVA eta max 10 power 3 power factor by kVA eta max 10 power 3 power factor plus 2 pi. Put values. It is 29.1 10 power 3 power factor is 0.8 only. 29.1 10 power 3 power factor 8 plus 2 into what is our loss? 450. So this comes as 96.27%. Right.